So we understand that velocity is the rate of change of displacement. And displacement we know is the change in position. Remember, this is how we defined displacement. Displacement was defined as the change in position. So let's try to plot a 1D motion on a graph paper. And it's a graph between the position of the object with time. So at time t equal to 0, the object was at x equal to 0. Then the object moved at x equal to x1 after time t1. So at t equal to t1, the object is at x equal to x1. And at t equal to some other time t2, the object has moved to x is equal to x2. So the object started from here, started moving in the east direction, reached here after time t1, and finally reached to point C at time t2. Let's name the other points also A, B, and C. Okay. Now, if you plot the position with time on a graph paper, it would look something like this. So a general representation of the variation of position of the object with time is given here by this graph. Okay. At time t equal to 0, the object was at x equal to 0. So that is plotted here, as you can see. I'm marking it with this green dot. At time t equal to t1, the object moved. The object changed its position and it reached at x equal to x1. So on the graph, this thing would be x1. This would denote x1, right? At time t2, it has moved to x2. So this this thing would denote x2. The change in position is the displacement. We know that. So now let's quantify change in position. It would be given by x2 minus x1, final minus initial position. Final minus initial position vectors will give you the displacement vector that is denoted by delta x. This delta x is actually this height. Yeah, this is x2, this is x1. So the difference between that is delta x. So this thing, this represents displacement, which is equal to change in position. How did we define velocity? It was the rate of change of displacement. So if you know the displacement, rate of change of displacement would be given by this, which is the velocity. Yeah, velocity is the rate of change of displacement. So delta x upon delta t. That's your velocity, which is x2 minus x1 upon t2 minus t1. So if you're tracking what was the velocity of the object when it was moving from B to C, only for this journey, yeah, for this journey, the velocity is given by x2 minus x1 upon t2 minus t1. So this is how you give the average velocity of the object. Okay, let's recap this once more. So we took an example of an object moving from origin to point A to point B to point C. Now, the object at time t equal to 0 is at this position, x equal to 0. At t equal to t1, it is at A. At t equal to t2, it is at B. And if we have to find out what, what was the velocity of the object when it was moving from A to B, that is what we have to find out. Okay. Now, to do that, you find out the position of this object here and the position of this object. So you get delta x first. Delta x would be the displacement, which is x2 minus x1. And you divide it by the time duration, which is delta t. So delta x by delta t is your velocity. What kind of velocity? It's average velocity. Average velocity only gives you the big picture. Let's say you started from your house and reached your school. Now, during your entire journey, were you traveling with a same constant velocity? No, of course not, right? You slowed down somewhere, you picked pace somewhere, you might have taken rest, maybe for a couple of minutes somewhere. So your velocity throughout the journey was not a fixed value. Yet, this thing gives you a fixed value. So what is it talking about? It is talking about the average velocity. Meaning, if you traveled at a constant velocity, you would take the same amount of time to reach your school. It's not telling you that you traveled with a constant velocity for the entire journey. It's just giving you an equivalent value of velocity, which would have helped you reach the school in the same amount of time. So, what if I want to find out exactly what was my speed at time t equal to 5 seconds, let's say, at a given time? If I want to find out my speed right at this instant, right at this moment, can I find that? If so, how? So that's where the concept of instantaneous velocity comes into picture. Instantaneous velocity. It's the velocity at that instant. So, for example, if I want to find out what was the velocity at time t3, not for the journey t2 to t3, but exactly at point t3, that is where instantaneous velocity comes into picture. Let's see how to quantify this and how to calculate it. Let's look at the motion of this mouse. This mouse was at x equal to 0 at time t equal to 0. And then it moves to x equal to x1 at time t equal to t1. And then finally it moved to x equal to x2 at time t equal to t2. What was its average velocity for the journey t1 to t2? The average velocity would be x2 minus x1 upon t2 minus t1. Now, what if instead of finding the velocity at a time interval, I need to find the velocity at a time instant? So what is a time instant actually? A time instant or an instance of time is nothing but a very, very small time interval. That's all it is. Okay. So if say I take this small time interval, yeah, this small time interval, it's almost saying that it is the time instant t1. So when delta t or your time interval, it tends to 0 or it becomes very, very small, that is when you get a time instant. With that understanding, let's move from average velocity to instantaneous velocity. So we know that V average is given by delta x by delta t. If you put limit on both sides, limit such that delta t tends to 0, you get this. Limit delta t tending to 0, delta x upon delta t. So when delta t becomes very, very small, delta x is also very, very small. Whatever it is very, very small, right? So limit of average velocity when delta t becomes very, very small is actually the instantaneous velocity. That is it. So this is your V instantaneous. And it is limit delta t tending to 0, delta x upon delta t. How do we represent it? In calculus, you would see from the first principle of derivatives, you would see that limit delta t tending 0 is dx by dt. So what did we learn then? V instantaneous is given by dx by dt. So if the time interval is dt, this thing is dx. This is how you find instantaneous velocity. So if we have the graph, if we have the position time graph, how do we figure out the average velocity and instantaneous velocity from that graph? So here's a motion for you. The mouse starting from origin, moving to point A, then to point B at different time intervals. If you have to find out the average velocity for the journey AB, you know this is the expression for that, x2 minus x1 upon t2 minus t1. What does it mean graphically? X2 minus x1 or delta x is this length or the perpendicular of this triangle, this right angled triangle. So delta x and divided by delta t, which is the base of this right angled triangle. Delta x by delta t or perpendicular by base. Using trigonometric relation, if this is theta, you can say that delta x by delta t is tan theta, right? So the average velocity is given by tan theta. And what is tan theta? For a straight line, tan theta is the slope. So what did we learn? If we have to find out the average velocity for a journey, let's say from point A to point B, point A to point B. You join the 2 points, you will get a straight line. The slope of that straight line will give you the average velocity. Simple. Yeah? Okay. How do we find the instantaneous velocity from the graph then? Again, tangent itself gives us the instantaneous velocity, but it's a different kind of tangent. It's the tangent to the curve at the instant. If I have to find out the instantaneous velocity at this point, let's say t3, t3 from the graph, okay? So what you do is at the point t3, you find out the displacement x3, right? This is the displacement. Now at this point, you draw a tangent. Draw the tangent to this curve. So that tangent will just touch the curve like this, right? You measure this angle with the horizontal. Let's call it phi. And then tan phi will give you the instantaneous velocity at t3. So this is the complete treatment of average and instantaneous velocity and how do we figure that out from the graph, from the position time graph. Let's practice some questions on this in order to get more clarity.